This video is going to cover all of the questions from the review. Feel free to jump around to the problems that you have questions on. So let's get started. On section 1, it asks us to determine if an ordered pair is a solution. So question number 1 says to state whether or not the following ordered pairs are solutions. So I'm first going to test part A. So is 2, -8 a solution? In order to test that, this is my x and this is my y. Plug those values in. -8 is equal to 2 minus 7. Now is that true? 2 minus 7 is -5. -8 does not equal -5. So the answer to A would be no. Is 6 -1 a solution? I tested in the first equation. -1 is equal to 6 minus 7. And I see that that simplifies. 6 minus 7 is -1. So it works for the first equation. Now I'm going to test it for the second equation. -1 is equal to 4 times 6 minus 25. And if I simplify, I get -1 equals -1. It works for my second equation. So the final answer is yes. Number 2. State whether or not the following ordered pairs are solutions to the system. Notice this time my systems are not equations, but inequalities. If I test the first inequality, I can see that I'm going to have -3 is less than or equal to -4 plus 7. As I simplify, -3 is smaller than +3, so it works for the first equation. Plug this back in for the second. -3 is less than or equal to 5 times 4 minus 2, and 18 is certainly bigger than -3. It works for both, and the answer is yes. I'm going to test the second one similarly. It's going to work for both, and we have a solution. Yes. In order to use substitution, I am going to first look for an equation that is solved for one variable. I can see that my first equation is solved for y. In the second equation, I'm going to replace all y's with x plus 2. So 3x plus, there's my y, x plus 2 equals 34. 4x plus 2 is equal to 34. Minus 2 from both sides. 4x equals 32 divided by 4, x equals 8. Plug it back in to find my second value. Y is equal to 8 plus 2, so y equals 10. My final answer would be the ordered pair 8, 10. On the second problem, I see no equation that's solved for y, but I see that this y is very close to being alone. So I'm going to add 4x to both sides of that equation, and my first equation is changed into -1 plus 4x. Now that I have that inside this second equation, I'm going to plug it in that every time I see a y, so 2x minus 8, -1 plus 4x equals -52. And let's solve. 2x minus plus 8, negative times a negative is a positive, minus 32x is equal to -52. I'm going to simplify. -32x, plus 2 is -30x. I'm going to subtract 8 from both sides. I get -60. If I divide by -30 on both sides, I'm going to get an x value of 2. I plug it back in, into the x, and I get -8 plus y equals -1. Add 8, y is equal to 7. So my answer is the ordered pair 2, 7. Section covers elimination. When I look at an elimination problem, I can tell that it's going to be that because the variables and the numbers are all lined up. I look for two numbers that I can add together to give me 0. I can see that in this x column. I'm going to add, 8 plus negative 8 is 0x. I continue to add. Negative 3 plus 5 is 2y. 1 plus 9 is 10. To solve for y, I'm going to divide by 2. Y is equal to 5. I'm going to go ahead and plug it back into y. 8x minus 3 times 5 is 15 equals 1 plus 15. 8x equals 16 divided by 8. X is equal to 2. So my final answer for 7 is 2, 5. Plugging it in, solving for number 8, I see that I don't have any columns that are going to add to 0, so I'm going to manipulate one of the columns to give me 0. Now if I decide to manipulate my x column, I'm looking for a common multiple of 3 and 8, which is 24. Kind of like a common denominator. I'm going to times the top row by 8, and I'm going to times the bottom row. Now if I times by an 8 and if I times by a 3, I'm going to get negatives of both of those, negative 24. I want it to be just like question number 7 where 1 is positive and 1 is negative. So I'm going to times the bottom row by a negative 3 so that I end up with a negative 24x and a positive 24x. So let's multiply the top row. I end up with negative 24x. A negative 9 times 8 is negative 72. Y equals negative 48. On the bottom, positive 24x, positive 12y equals negative 72. Now, if I add my rows together, the x's cancel out. I'm left with negative 60y is equal to negative 120. If I divide it by negative 60, I end up with my y value equaling a grand total of 2. Plug in to find my second value. Plug into whichever one. Negative 3x minus 18 is equal to negative 6. Add 18 to both sides. Again, negative 3x is equal to 12 divided by negative 3. X is equal to negative 4. My final answer, negative 4, 2. And that is elimination. Now let's take a look at some word problems. So number 9 states, Joe and James are saving their allowance to buy laptop computers. James has saved $30 already and earns a $5 allowance each week. Joe has saved $10 and earns a $10 allowance each week. Now here's the part where it tells me what I'm trying to find. At what week will Joe and James have saved the same amount of money? So I want to know when their totals are going to be the same, and how much will they have saved. So I want to know what my total is, and I want to know how many weeks it will be until they're the same. So remember, when you read word problems, you're looking for grand totals. Now I don't have any grand totals. I have a starting amount and an amount that they're adding to an account, but no grand total. So I'm going to put T equals what I start with plus what I'm adding to my account. Now I add it more than once, so 5 per week. My second equation is going to be T for total. I don't know what Joe's total is, but I do know it starts with 10 and he adds 10 per week. How do I solve this? Well, remember, I want to know when the totals are going to be the same. I'm going to use substitution because I have T equals. Every time I see T down here, I'm going to replace it with 30 plus 5W is equal to 10 plus 10W. Solve for W minus 5W minus 10. And if I simplify everything, that gives me 20 equals 5W divided by 5. W equals 4 weeks. And I want to know, and how much will they have saved? They plug that back into one of my W's. 30, my total is equal to 30 plus 5 times 4. So 30 plus 20, my total is equal to $50. 4 weeks, $50. Let's look at our second word problem. At a restaurant, the price for 3 salads and 2 glasses of lemonades is $14, and 2 salads and 4 glasses of lemonades is $12. All right, what are my totals? Remember, that's what I'm looking for with word problems. One of my totals is 14, and one of my totals is 12. Well, what makes up with that 14? 3 salads, I'm going to use X, and 2 glasses of lemonade, so 2Y. I'm going to state that X equals salad, the price, the money, and Y is equal to the price of the lemonade, because we know how many we have of them. 12 is equal to 2x plus 4y. Now how can I solve this? Since all my variables are lined up, I'm going to use elimination. I'm going to manipulate my y column to be the same. I'm going to multiply by -2 so that I can have a -4 to pair with this +4. That gives me -28 on the top row is equal to -6x minus 4y. I'm going to rewrite the bottom row. 12 equals 2x plus 4. And let's solve. -28 plus 12 is a -16 is equal to -4x, and the y's cancel. I divide by -4 and I get x is equal to 4. So x is the salad, $4 a salad, and now I'm going to find my y by plugging it back in. 14 is equal to 3 times my cost per salad plus 2 for my glass of lemonade. 14 equals 12 plus 2y minus 12. 2 is equal to 2y, and I divide by 2 to find the cost of my lemonade, 1. So $1 per lemonade. All right. Now that I'm done talking about story problems of equations, we're going to move on to all things inequalities. So when I'm graphing inequalities, I'm going to start by graphing a normal line. So starting at 3, I'm going to make this a little thicker. Starting at 3, and my slope is -2, so down 2 spaces over 1. And I can do the reverse. Remember, graphing, I need to pay attention to this right here, whether it's going to be solid or dotted. Because it's not or equal to, I'm going to make a dotted or dashed line, arrows on both sides, and it says that y is less than. So I'm going to shade below the line, so straight down is below the line. I'm going to shade on this side. Let's look at our next example. My y-intercept is at -4. My slope is 3, so up 3 spaces and over 1. This time, this says or equal to. So I'm going to make a solid line. And because this says y is greater than, I'm going to shade above the line. And that's graphing inequalities. Now what do I do when I have 2? Well, I'm going to put them on the same graph and find the overlap. So if I graph the first one, I start at 2, I go up 2 and over 1, and I can go backwards. This one's gonna be a dotted line, and I'm going to shade below the line. If I choose a different color, starting at 2 again, my slope this time is down 4, 1, 2, 3, 4. Okay, also a dotted line, and I'm going to shade below the line again. So below. Now where's my overlapping section? Make sure you shade that dark. It's between these two lines. All right, let's look at our second one. If I start at 2 and my slope is 1/2, up 1 over 2, I look at my inequality, it says dashed. I want to shade below the line, so we're down here in this section. My other line starts at -3. Let's change colors. -3, up 2 and over 1. This time my line is solid. Whoops. And I want it to be y is greater than. So I'm going to shade above, and I can see that my double shaded region is going to be right here in between these two lines. And that's graphing inequalities. Last but not least, let's talk about that word problem. So Kelly works for her dad to make $6 per hour and also works for Jana's mowing service and makes $14 per hour. She needs to make at least $84 and can work at most 10 hours. So whenever you read a word problem, first write down any totals you have. So I have 84. It says at least. So remember, at least would mean that's my bottom amount that I want to work. So going back to elementary school, the alligator mouth cannot be eating the smallest amount. So less than or equal to, what makes up that $84? The $6 she makes from dad, we're going to use that X, plus the $14 she makes from Jana, Y. So the first thing I'm going to come over here and do on my graph, this is Jana's hours. Okay, because Y stood for how many hours I worked for Jana, and these are dad's hours. Let's write our second inequality, because this is a system. Kelly can work at most 10 hours. So here's my total of 10, and at most means that's the top limit. So the alligator mouth needs to be eating the largest thing. Kelly can work exactly 10 hours. So I'm going to put or equal to, and I'm going to put X plus Y. Let's go ahead and graph these. Now in order to graph, I'm going to solve for Y. So on this first inequality, what does that turn into? Well, we're going to minus 6x from both sides, and I end up with 84 minus 6x is less than or equal to 14y. Divide everything on both sides by 14, and I am left with 6 minus, divide the top and the bottom by 2, 3 over 7x is less than or equal to y. How do I graph that? I find my y-intercept, so up 6, 1, 2, 3, 4, 5, 6, and I'm going to go down 3 and over 7. Down 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7, and I'm going to make a dot. Now it's going to be a solid line, and it says it's eating the y, so y is greater than. So I'm going to shade above the line for the hours I want to work for Jana, and that I want to work. And then I'm going to look at my second inequality, solve for y again, minus x. My inequality says 10 minus x is greater than or equal to y. So my y-intercept is 10 up here, and I'm going to be going down 1 and over 1, down 1 and over 1, down 1 and over 1. You can use a straight edge, okay, but my line is going to look like this. It says y is less than, so below the line, and I can see the section that's already shaded is going to, and the section that's going to be double shaded is this region right here in between as my solutions. So the two follow-up questions on this problem ask me to list a possible combination of hours that Kelly could work in both jobs that meets the criteria that we set in problem 15. So if I'm looking at my graph, remember the possible combinations of hours she can work are the ordered pairs or the points that are in the shaded region. So for example, this point right here would be a possible combination of hours. That is 2 hours spent working for Dad and 7 hours working for Jana. So 2 hours for Dad, 7 hours for Jana. We could write that as an ordered pair since we stated them as X and Y, 2, 7. The last follow-up question says, can Kelly work for 2 hours with her dad and 3 hours for Jana? How do you know? So I'm going to go back to my graph, 2 hours for her dad, 3 hours for Jana. So there's 2 hours for her dad, 3 hours for Jana. Is that in the shaded region? And the answer is, will it work? No. And I can say a couple different things. It's not in the shaded region. Or I could have calculated it. Well, does it meet my criteria? 2 plus 3 hours is less than 10 hours, which meets that criteria, but doesn't meet my money criteria. 2 hours for Dad would be 2 times 6, plus 3 hours for Jana, 3 times 14. What does that equal? 12 plus 42. That's a grand total of $54. Does that meet $84? No, it falls short. So, or I could say, no, she will only make $54. And either of those solutions would work. If you have any additional questions, please don't hesitate to reach out.